Okay, let's start then. Hi everyone, I am Dario, and thanks for coming to see this talk about performance testing and benchmarking for virtualization. So let's start. What I have here is really non-comprehensive list of tools of testing, benchmarking, CI tools that exist already, that are out there and can be used. And the purpose, the aim of having this list up was to give the idea that there are quite a few of them already, as we probably all know. So, I mean, I hope you don't think that with this talk I am going to talk about and propose to use yet another one. Will I? Of course I am. And, well, that's actually not entirely true, and we will see about that a little bit later. But let's introduce the subject of performance benchmarking with thinking about how you would assess the performance impact of, let's say, a change in the code. For example, let's say that the change is in the Linux kernel, but it, well, theory could be anywhere. And what you do for figuring out whether this change brings performance, any difference in performances, so better or worse performance, you run a benchmark without the change applied. Then you run the same benchmark, actually most of the time more than one benchmark. You rerun them with the change applied, and then you check the difference, if there is any. Now, this is what you do for, let's say, Baremetal benchmarking. What about if, no, sorry. What about if we put virtualization into the picture, into the equation? Then turns out that things becomes a little bit more complicated because there are quite a few more cases that you have to think about and actually go checking. This is just an example. So the example where you have to consider all the cases when the change that you are interested is either nowhere, so neither in the host kernel nor in the virtual machine kernels, or it's only in one of them, in one of these places, either on the host, only on the host, or only on the guest, or it's in both. And you have to run the same benchmarks in all these cases and figure it out. Of course, this depends on your use case, on the workload that you are interested, but in general, it could be like this. Also, well, yes, and of course, one of the other differences is that in this case, the benchmarks, yes, they still run, but they run inside the virtual machines. Quite obvious, but let me just point it out. Let's now focus on, for example, these two situations where we want to see the difference, whether no change whatsoever or change applied both host and guest. I mean, is it really always the case that this is okay, this is enough, so we want to check the performance when running only one virtual machine? Maybe, but maybe not. Maybe we want, we also care about use cases where on the host there are multiple virtual machines running. And so now what is happening is that you have to rerun your benchmark, not only in all these different use cases, but also, and not only in just one virtual machine, but in multiple virtual machines, and most of the time at the same time. So basically what you would need is some tool that would help you, as for example the developer of such a change, of the change that we are talking about, tool that would help you to run benchmark inside virtual machines. That's the first thing. But you probably want to be able to run benchmarks inside multiple virtual machines, and you may want to be able to run the benchmarks inside multiple virtual machines at the same time, and if they run at the same time and you are interested in the results of all these benchmark runs in all these virtual machines, then you also have to think about a way of making sure that the benchmarks are running in a kind of synchronized way, because you want, I don't know, all the CPU benchmarks to start at the same time. And if the benchmark, if each one of these benchmarks does, for example, multiple iteration, then also the single iteration inside the benchmark needs to be synchronized. Otherwise, the results that you will get are, well, not usually not the one, not so interesting and may not want maybe not the one you want. So let's speak briefly about this tool called MMTest. It's not really a new tool because it's basically a test suite, a benchmarking suite, which is out there since quite a while. It was born as a tool for testing and benchmarking memory management code in the Linux kernel. The original and still the original author and still the maintainer and main developer is my colleague at SUSE, Mel Gorman. And but yeah, it has evolved a lot since these days. It's not only MM only. It lives there at that GitHub address. You can go try it and yeah, and talk to us if there is something that you don't that doesn't work for you or have questions. You can open GitHub issues, but we are not yet monitoring those very actively. So the best thing is to email either Mel or me. And yeah, what is it? It's a collection of Bash and Perl. And what it does is it fetches, it configures, it builds, and then it runs one or more benchmarks. It also collects and stores on the file system the results, and it lets you compare the results of different runs. And we have, and there are statistics that you can look at, and you also can, and it also can plot. And it supports what we call monitors. So basically, it is a very nice feature, according to me at least. While you can configure the things in such a way that while the benchmark are running, then the tool will sample for you stuff like top, VMstat, MPstat, and then you will have these numbers as well. And also, it's also integrated, at least up to a certain extent, with perf and trace, so both monitor and tracing if you want. There are quite a few benchmarks that are already available, already pre-configured there. If you just clone the sources and want to try one of these. Each one of them is there with multiple, let's say, multiple and different configurations. There is a directory in the code where all the configuration files are stored, and there are multiple configuration files for most of these benchmarks. Some of them, and there are also scripts, let's say, that will generate more variations, so even more configuration files, so even more diverse configurations, again, for these, for the various benchmarks. This is an example of a configuration file. It's just a collection of Bash exported variables. Of course, there are some, this one here, which are more or less common to all the benchmarks. This is the monitors that I was saying before. You can choose which one you want to be active while running the benchmark. And there are some other which are specific for the benchmark. Now, for fully understanding them, you have to know at least a little bit what the benchmark does and how it works. But once you do that, it's pretty easy to, for example, change the number of iterations that you want a stream to run for each run, for each benchmark, or the placing policy with for OpenMP, or the build flags, or whatever. So yeah, that's how you use it. So you use the script which is called run MMTests. .sh, you specify the config file, you specify a name for that particular run, then you do another run after you having, I don't know, applied your change the configuration, whatever it is that you want to measure the difference between, and then you can compare the results. You can use these compare kernel wrapper scripts, which has its own parameters, or you can use directly these other facilities which MMTests provides, and which I'm showing you in a little bit more details. So this one, for example, is for seeing the actual results and the comparison, because here you see, so in this case I have run netperf with different packet sizes, and these are the absolute results, the absolute numbers from the first run. These are the absolute numbers for the second run, and these in parentheses are the percent differences for each packet size. You can have an overall comparison of these two runs because, as we saw in this case, the benchmark was run with different packet sizes. Is there a way to aggregate all these results in one and have an overall view of how the benchmark went? Well, there is. It's this one. Yeah, basically we do the geometric mean of all the ratios, and we use the geometric mean because the people who understand statistics way better than me thinks that it's a good type of mean to use, so I agree with them. And yeah, and these are the monitors. So basically, again, you can have printed, you can ask MMTests to print the comparison between the values that it has sampled for these monitors during the two runs. And this is another example of monitors. This one was just monitoring the duration, which is very trivial, and this other one was actually using perf for collecting these metrics. Migrations, context switches. And yeah, as I said, you can plot. Okay, so couple of beware of, which are, the first one is that it pretty much, I mean, it requires root, you can even run without root privileges, but well, it depends on the benchmarks, and it depends on what you want to do. For example, you can ask MMTest to change the CPU frag governor to performance while running the benchmark, and if you want to do that, that needs to be done with root privileges. Or change other parameter, I don't know, is enable or disable transparent use page, all these things that may be of interest to you, which do require root privileges. It tries very hard to undo all it has done, so to leave your system in the previous state as before, but really this is thought to be used on test machines, which ideally you would be able to, after having run the benchmarks, like reinstall or redeploy easily, rather than on your super precious workstation, which then can be messed up a little bit, as hard as we try not to. And it also fetches the stuff from the internet and then runs them as root, which is maybe not the most secure thing that you want to be, especially again in not something which is a cattle machine that you will redeploy as soon as possible. Internally, the way we use it internally is that we don't fetch from the internet. We fetch the benchmark, then vet the result, what we got, and then put them in a mirror. And it's pretty easy to configure MMTest in such a way that it will fetch for a mirror. So you can set up your mirrors and mirror and use it like this. It's a little bit less scary, let's say. So I said I had virtualization in the title. I spoke about benchmarking virtualization in the first slides. Can MMTest be used as that tool which allow you to run benchmarks inside virtual machine, multiple virtual machines, synchronized, blah, blah, blah? It can, because I am working on extending it so that this is becoming possible. And what you do is to use this different script. So instead of run MMTest, you use run KVM. Actually, it doesn't even have to be KVM because it uses virsh and libvirt, so it can be even anything else. But yeah, that's how it's called for now. And it's pretty much the same as before, with the difference is that, well, these two parameters, just ignore them for now. But you specify, in addition to the config file and the name of the run, the name of a VM. So again, for now, this is pretty much a work in progress. So I will have a few words about it later, but there are, I would say for now a few times during this presentation because it's in active development. So for now, the virtual machine has to exist already and has to be known to libvirt already. So basically what MMTest does is virsh start the name of the virtual machine you have provided. If it doesn't exist, bad things happen. And also they have to be set up in such a way that the host can SSH into, can reach the virtual machine over network and can SSH inside the virtual machines passwordless. So what it does is start the virtual machines, it copies MMTest inside the virtual machine, run the benchmark inside the virtual machine, then store some logs both about the host and the guest, from inside the guest, and then it fetches back the result from inside the guest back on the host, and that you run the comparison tools. And besides adding the virtual machine name as a parameter, all you need is to add this additional variable in the config file, which is basically the IP address of the host. And yeah, I said also that I wanted a tool which can run benchmarks inside multiple VM, and yes, it can also do that. So instead of just specifying 1, you specify 2, 3, 4, however you need. And it does exactly the same thing with multiple starts, multiple VM, copy MMTests inside all of them, run the benchmarks inside all of them, blah, blah, blah. Synchronization, the synchronization that I also mentioned. So basically, this is implemented, and as said before, host and guest needs to be able to talk over network, and it's over network that synchronization protocol has been implemented between basically the run KVM script running on the host and the run MMTest script running inside the guests. And this synchronization protocol, as said, right now happens over the network. In future, it can happen using other means like Virta.io VSOC, Virta.io serial. But let's see what's more convenient. And it's based on exchanging messages through NC, the NC tool. It could be gRPC, it could be reworked to be gRPC, anything more, I don't know, solid. This is what it is right now. And it's a token-based protocol. So basically, the benchmark inside the VMs knows that they can only go so much farther, let's say, until the point where they want to start an iteration of one of the benchmarks. And when they get to that point, they send a token to the host. The run KVM running in the host collects all the token, it knows how many virtual machines there are, and as soon as all the virtual machines have sent the proper token, it realizes that they are all at the same stage, at the same place, and they can continue. And so it sends a token itself to all the virtual machines to let them continue. And so it's a barrier protocol working like that. Right, and basically what you see here in this screenshot, of course I could have shown like the logs with the timestamps, the various phases aligning and happening at the same time inside the virtual machines, but it would have been, I guess, hard to read. So this is a simplified view, but I mean, you can try and check the timestamp and see that it actually works, but you also can see from here, I hope that at least have an idea that, yes, in these two virtual machines, the benchmarks are actually running synchronized, because this is the CPU load caused by the benchmarks running there, and you see that it matches pretty much. This is probably the time where an iteration ended, and here another one started. This is a very simple example with only 2 virtual machines. I have an example with 30, but it could probably be as hard to read as the timestamps if I would have shown it. And yeah, so this is a tool which right now is used for developing, let's say. So basically, it's you as a kernel, but it can be you can be doing development in somewhere else. You are interested in benchmarking the effect of the changes that you are making to the code, and so you use it, and yeah, and you get the results. Can it also be used inside a CI loop, for example, to automatically monitor and perhaps automatically report regressions of new kernels, new packages, and stuff like that. As a matter of fact, yes. As a matter of fact, it's what's happening within SUSE because the performance team is doing exactly that. They are using another tool on top of MMTest, which is the one implementing the actual CI loop, and it's called Marvin. I'm not going into details now. There is this talk, this is a link to the recordings of a talk which you can watch and have more details. What we plan to do is pretty much the same thing with some variations in the virtualization team, which is where I am working, because we already have an instance of Jenkins which is building our packages for all our distros, then it's installing them in different machines, each one running a different distro, and then running already some functional tests. So what we would like to do is to plug MMTest to this infrastructure and have also performance benchmarking on top of these, and be able to check for performance regressions and stuff. So there is, as I said already, it's an ongoing development effort. There is a lot which I am doing or plan to do on specifically on the, let's call them virtualization extensions to MMTest, but there are also areas of improvement of MMTest itself. This is something which is public on GitHub since a while, but until now it has only, and up to a certain extent it still is, it's only been considered and regarded as an internal tool, while my idea would be to start making it a little bit more usable and available for people even outside of SUSE and of our teams, which is why I'm giving this talk after all. And yeah, so these are a list of things that I plan specifically for the virtualization extensions, so running stuff not only in VMs but also in containers, maybe Kata containers, which is another fancy thing. I want the VM starting and stopping process to be more parallel. Right now is a little bit too much of a sequential thing, which is not fancy if you have to run the benchmark inside 30 or 60 virtual machines. I want to have some VM management, stuff. Yeah, then there is documentation. Yeah, that's pretty much the documentation that you find about it, but it will get better. And for now, if you really go there and try it and miss the documentation, which you will, and you maybe also find issues, I do encourage you to, as I said before, either interact with us on GitHub or email either Mel or me, and we will see what we can do to improve the things. Yeah, which is pretty much what I just said. Give it a try. Tell us what you think, whether you think it could work for you, whether you think you would need something different, and we will be happy to see if we can do what we can do about that. And yeah, here you can find a little bit more of information about myself. And with that, I am happy to take any questions. Thanks. I saw two hands. We have one here.
I somehow missed why the synchronization is necessary.
So it depends. Yeah, right. I have to repeat the question, and the question was why the synchronization is necessary. So it depends on on what you want to do, on what is your use case and your needs. Of course, if you are interested. So here I'm thinking about a scenario where you want, for example, okay, let me just go here. In this case, this is an actual real case where I use this tool. In this case, I was running Stream inside 4 virtual machines, okay? And I what I wanted, they were pinned to different physical CPUs. So in theory, what I would expect would be that on each virtual machine, I wanted to see the same or similar stream performance, because the goal was to check whether the isolation between them was working by pinning them, by partitioning the resources. Okay? For doing that, I need to run the benchmark inside all the virtual machines, and I care about all the results inside all the virtual machines, and I cannot afford to have results from a run where it happened then that stream, for example, it did 5 runs. Okay, what if I don't do any synchronization? What guarantees me that I don't know, inside the first virtual machine, the first run start, then it finished, then the second run of stream start, and in the meanwhile, in the other virtual machine, they are running in different stages of the same benchmark. Okay, so I need the gating. I need if this is not what you want, if you just want to, I don't know, have some noise around and run a benchmark inside the virtual machine, and you care about the performance only that virtual machine, then you don't need this, and you don't have to use this. I mean, you just use it without this synchronization. But there are use cases where it's important, at least according to me. And perhaps I haven't looked hard enough, but I haven't really found this particular feature of gating and synchronization in many other tools which are available out there. Yeah.
Why do you actually need stateful VMs like with images and everything? Have you tried creating like ephemeral VMs, like by virtualizing first file system? Like have you seen like Baremetal by any returners? Right? Just virtualizing the host and creates the VM which looks exactly the same, right? So you could have used it there, so you don't need to copy this MMTests and download like 10 VMs. Just say create 10 copies of your host.
Yeah, so the question is why we are using full-fledged VMs instead of using other solutions like creating VMs dynamically out of the host file system and stuff like that. We are just not there yet. It was easy enough to have focus on the part which implement this synchronization thing, and for having the benchmarks actually running in VMs, just virch start something and then implement this. As I said, I ideally would want to be able to continue developing on this and to be able to use it for run benchmarks, even not necessarily in VM, even in containers. And I want to add some VM management capabilities, which includes being able to maybe define VMs with XML file, auto provision then, and absolutely, I mean, even something like that would be more than useful. It was just the easiest way forward, way from where to start, basically. Yeah.
What is your real matrix for testing? Do you test Windows hosts, Windows guests, maybe locale guests?
So this is actually currently in use as I said, inside SUSE performance team, and what they use it for is for testing and identifying regressions that may be happening in our product. So basically we test different, the commercial version of our product is SUSE Linux Enterprise Server, and so we test different version of the operating system and see whether between version N and version N+1 we are introducing regressions. And we also, they actually, because it's not strict, I'm doing development on this, but it's not strictly my team, they also track whether there are regressions between mainline and our kernel, which has all the patches which we include. And it's also used for doing kernel development and figuring out whether, as I said, changes. But the kind of guests which are automatically tested right now are these ones, so our products, basically. But nothing prevents you to, I mean, it's again a matter of adding some virtual machine management provisioning, whatever, at which point you will, if you are able to install Windows and start a Windows VM, then you can use it.
And if I have time, I would like to ask one more question.
Yeah, sure.
Last question. Thank you. So how do you put kernel? Do you use direct kernel boot or some?
You can, that's the, sure, sorry. Well, the question was whether how do we boot a specific kernel that we want to test. So whether we use direct kernel boot or something else. So this is what this -k parameter does. Again, that's where I started, and my use cases was not much about testing different kernels, but about testing, so running a benchmark inside multiple virtual machines with different configurations, okay? So for this use case, I don't care about, I'm fine the virtual machine booting with the kernel which is installed when I provisioned it, when I installed the operating system on it. And so if you use this option -k, which is keep kernel, it basically just boots the virtual machine which whatever kernel is inside this image of the virtual machine. But you can, if you don't use that option and use other options for providing the kernel, then it uses direct kernel boot for booting your kernel because you have your changes there and you want to test them. Yeah. 0 minutes. Thanks.